Okay, so serverless, most all things are managed. There's things that you need to know that you learn today. It's cost effective, and then when you one of the things that you need to configure on the Lambda is memory size. So by default, it's 128 megabyte. So you can increase it. This is you only configure memory size, and then you will receive CPU network resources based on that memory. And there is a limit, like when it comes to processing, like that function 55 minutes, but if it runs more than 30 seconds, then I want you to consider like some different services, different models such as EC2 or ECS, because it costs more. Every running millisecond you pay for it. Okay. Number of requests and how long it took. That's the two factors that you pay it. But again, based on the memory size. If it's smaller memory, you would pay less, but if it's bigger memory, you would pay more. And then your code is stored in S3 and it's encrypted. No service to manage. And basically you write your code, and that code is in zip uploaded to S3, and Lambda reads your code from that S3 bucket as a zip file. Or the newer feature, it's not new now, but starting last year, they supported this container image that you can run in Lambda, but I'm not sure how mature this part is, but it is still there. But I don't think people use this that much. Instead, there is a container, it has the container service, but again, there is a chance. Like if you want, then you can use this container image. So cost is much optimized, it's effective. And with Lambda, it's function as a service model. So you don't need to manage its scaling. So while we were learning EC2, like it was on us to manage its scaling. We created EC2 scaling and configured this. But in terms of Lambda, it's not on you, it's on AWS. And it can make sure that performance is consistent at any scale. Like when your application is scaled, then it can still perform that, can provide that performance. And then there are some other features, Lambda, that you can easily integrate with the step functions. But the step function is something much bigger than just Lambda. You can integrate that with many services, I think 20 plus services. Not only that, AWS step function has AWS SDK. That means you can call 200 plus API calls. And this is handy in real life. When you write these event-driven cloud native applications, you would have components all over this cloud, and you need one place to orchestrate all of them. And that's what the step function is. And then its model, as we talked, based on the memory size, it allocates proportional CPU, network, and disk I/O. And then the serverless, like everything is much easier on your side. Like when 10 years ago, 20 years ago, maybe if you are getting hired as a software engineer, they might be asking you like multi-threading and collision, all this lower level stuff, but now it's not on you, it's on the AWS side. And it's all solved by the cloud provider, and instances are isolated, so there won't be any such collision that competing for one element. There won't be something like that. And in S3, there could be even unlimited number of connections. When it comes to like AWS RDS, like it's on you to manage like how many connections it accepts. But when it comes to S3, like you just connect to it, it doesn't matter. So that's the power of serverless. And one of the students like asked, it would be great if you give us some real life examples. So real life serverless examples, you can find this website, server-stat.com. If you click on this, like it's in the slide, if you click on this, then you will find like real life examples. Also, how I learned about real life example is I also read Medium blog. So that's also you can find real life blogs. In Lambda, so in this lesson, we will directly work on AWS console where we can edit our code. In real life, you use this AWS serverless application model, so SAM, AWS SAM, and you download this, and then in your VS Code, you write your Lambda function. Not only the function code, also you write its infrastructure. It's template for creating its infrastructure. So what I mean by the infrastructure is Lambda works in conjunction with API Gateway and DynamoDB and many other services. So you can create that technology stack with this SAM. You write one template and then just one click and then it launches. It deploys your Lambda and then it also creates or updates the infrastructure. And then later you can use this CI/CD. You write your code and it's uploading to cloud and making it Lambda. It's done by this SAM. It's automated. You just write your code, write AWS SAM deploy, something like that, small command, and then it does everything on the default. It uploads your code to S3 and then deploys it. And then you just pay for how many requests you have and how much that request took based on that memory size of the line. In Lambda, you have execution role, and that's something when we create a Lambda, we attach IAM role. That's required. That's identity-based role. That's what execution role is. So execution role is what that resource can do. And also in Elastic Container Service, you have the same role, execution role. And then where you write like what services your application can access. And then when you do that role, what happens is that if you remember, like when you assign a role, it makes call to AWS SDS and receives temporary token and then makes the actual request. And then SDS, this role, the advantage it provides is it provides automatic token rotation. And then not on the execution role, you can also write resource-based policy directly on Lambda. For example, in API Gateway, you cannot add in API Gateway when you want, like you make call to / like API.com, something like that case. Let's say it invokes a Lambda function. In that case, there is a connection between API Gateway and Lambda. And how you allow API Gateway in Lambda is by writing resource-based policy. So you don't associate API Gateway with any IAM role. Instead, you have to allow that. Let's have something, So this is what I just discussed. So S3. So this is like another example of a resource-based policy. In our previous lab, what we did is we upload an object. There is an event that triggers SNS, that sends message to SNS. Similarly, we had three options. Then what policy you have to write is this policy. Same as very similar to SNS. Like here, S3 invoke the function, which functions that you defined on this resource property, but then only this my bucket. When there is this my bucket can invoke this function. Let's say, for example, it's a new object. A little bit refresher on this policy. Okay, Lambda, so it's a function, and you have already written so many functions. And when I was starting coding, so what happened is I write a function, and then the code runs, but it was not running my function, and it took me hours to find out why. And then I realized that I have to call that function, right? Like invoke that function. Otherwise, it will not be executed. Same thing here. Lambda it's a function. You have to invoke it. And then this is what triggers. In this case, it's like very similar to the fundamental. So we have to call that function in our code. In the cloud, scope is bigger, but still you have a function that like other services are calling it. So triggers can be like some other life cycle events, such as object is created in S3 bucket, or user is created in user pool in Cognita, something like that. If there is some sort of event in your account, then you can trigger Lambda. Second thing is, this is also most popular use case that you can provide RESTful APIs. The next thing you can do is, let's say that like you want to read some data from data stream. Like there is something, there's a service called Kinesis, which is very similar to streaming popular technology like Kafka. Kafka and Kinesis, they are similar. And what they do is, you can think of this way. Kafka, okay. Kinesis it's a streaming service in the AWS cloud. That's basically very similar to Kafka is. And if you now, for you, it would be much easier to learn like such technologies because you already know what SQS is, right? You know what SQS is, right? You have application A and B, and you decouple that application with SQS, and then the consumer pulls the message. The Kafka architecture is similar. The Kinesis architecture is similar. It pulls the message from the source and send it to the consumer. And then all the features what Kafka provides, that's similar to what we discussed about applications in Kafka. So for example, there are, I think, 3 things. So it improves the throughput. That's the biggest reason that people use these streaming technologies, and then fault tolerance and improve performance.
Kafka can have multiple.
Yeah, more future. Yeah, exactly. It's similar to SQS, but that's I think that's where the similarities end, and then you have more. So basically, like more future. Like the idea is, yeah. And if you want to read like some sort of those kind of services, you can also read some data using Lambda, and also you can set schedules to trigger that Lambda. Every day at 9 a.m. or 10 a.m. you can run Lambda. So because of these reasons, there are many services that can call Lambda. And then Lambda is a function with one parameter, event. Okay. And that event can exist in different forms. Like depending on who is calling Lambda, event object is different. So for example, this is something from, I think I can show you this. So if you go to Lambda, we write some Lambda, I'll show you shortly. Okay, I'll just go to one of the existing functions. So step function 2, it's a one simple function. There are no triggers in here currently. Okay, I wrote this code and I want to test how my code works. In that case, you would want to click on this test. In order to test it, you have to create this event, like the sample event. So, and this is here, if you want to create, you can just hello world this, you can build your own event JSON. But this is how that event looks like. When it's called by API gateway, the event object looks like something like this. You have body and you have path. So based on that, you can do computations. And then if you want to read query string, it would be in query string parameters attribute. And if you want to see the path parameters, you can also see this is path parameters, and this is the value. This is key end value. And you should also see something like HTTP method. Path is here, HTTP method here. So based on this, you can write some basic APIs, backend APIs. For example, if HTTP path is like resource name, let's say course, and then HTTP method is paused. In that case, you can store the data. Next, in your next if-else branch, you can say like if HTTP method is get, then you can return all the resources, all the courses, for example. And if there is a path param, like a stash ID equivalent to some value, then you can get an item by a key and return it. Or if you want to do some searches, then what you can do is send your parameter, like a search criteria as query string, and then query string that you can read it from this event object, and then you can like expand your if-else branch for each HTTP endpoint. That's exactly what we will do. Like it's very basic. And similarly, API gateway is something like that. And the S3 bucket, I think we have seen that. When it comes to S3, put the event object is changed. Now it's records, and this is an array. And then it includes like S3 bucket information, and then that object information. That's what these triggers are. Now we have these many triggers. These triggers can be categorized into three categories. First thing is synchronous, asynchronous, and then one extra. But this is something that in the beginning, when you add the trigger, so let's say that if you want to add a trigger, who can trigger this Lambda? And you can select this as far as API gateway or application load balancer and DynamoDB, like move on, like you can add these triggers. In the beginning, like you would not do anything. You would select one of them and then hit it with that trigger. But under the hood, how it works is different. And like junior to mid-level engineer, like they don't care about like this detail, but when you advance, like it's very important. So for example, based on like how it calls, you can do something. Yeah, I will break this 1 second once I talked about this. So services that can call Lambda synchronously, and then there are services that call Lambda asynchronously. So synchronous is straightforward, like the traditional way. I break it on this in the last SNS SQL lesson. If you remember, like it's directly calls it, and if there is an error, then they might retry. Like under the hood, this time that does that. This is pretty straightforward. Like you have the, for example, API gateway. You have API, so you receive send request to API gateway that calls the function synchronously and receives the response by end result from the Lambda and return back to the client. This is synchronous. Like RESTful APIs, they are synchronous. And that's what they get. And then application load balancer. With ALP, we also tend to write REST APIs. That case also in REST API, like you make something like you for example, say I want to get a list of courses information. That case, it has to be synchronous. Otherwise, you cannot receive your final result. the other thing, so this is the like physical services, and this lambda at edge. So we talked about on edge server we can run some small code function. When you have that function, that lambda is triggered synchronously. And then this is, we will learn on day 3 of this week. Cognita, when you add this, like when there is a new user, you want to trigger a lambda, and that's also done synchronously. Asynchronous, and you already know what asynchronous, I talked about that in the Synthesis quiz. Let me ask you a question, how you make two services asynchronous? Like messaging, right? You put something like queue, SNS, Kafka, event bridge. Like put something in it, and then it's asynchronous. And asynchronous is like the pattern is fire and forget. Like it's like completely decoupled. The advantage is like when there is a new requirement, you can add it easily. It's like plug and play. You plug new API and then like it puts nothing. Like H3, for example, there are 8 services and now there's 250 plus services. And how they did this, like they have this decoupled approach. This is you can. You're right. Yes, this is how they work. And this event, so now there is a service, there is a lambda, and there is a queue in between. This queue you would never see, like it's managed by AWS. You would never see, but this is how it works under the hood. Like this is other services such as S3, SNS, and these services they call Lambda asynchronously. So this CloudFormation is we will learn this on the last day that this is used for automating this automation of this deployment and the configuration of services. CloudWatch can also trigger Lambda, and this is asynchronously. And SQS standard also can trigger this asynchronously. We have two types of queues, SQS standard and FIFO. So standard can trigger the asynchronously, and the other one is, I think, synchronous. So basically, so this is event queue, and then you have Lambda, and this is not only used like by AWS. Makes sense? And then what happens is that, like as you already know, these services in the list, they send request to Lambda. As soon as that message is put into this queue by AWS, then they receive success. And then it's on your function to handle it. And then for this, like if it's successful, then that's good, yeah. If it's failed, then you can also send it to another queue. This is something that we call destination. In Lambda, so we will learn about these configurations today. Destinations. Okay, we just learned it. So add destination. Notice here, it's asynchronous invocation. And then if there is a failure, then you can put it to like queue, and then like let's say this queue is our dead letter queue. This is okay. So this is we are learning in the like we are learning digging into more into this Lambda features. This destination, like when I was learning that, I had no idea what destination is, and now you have some idea what destination is. And if your Lambda is triggered by, let's say, API gateway, it is not applicable, right? Do you follow that statement? Like, for example, let's say that your Lambda trigger is synchronous API gateway, or put it our load transfer. In that case, it's done asynchronously, and there is no such thing like event queue and those things. Yeah. And in this lesson, we will add API gateway here. When you do so, like this definition is like we don't need to touch this one. It's not applicable in our case because lambda calls synchronously, and there is no such thing like Q. If there is an error, then you would receive the error immediately synchronously. When it comes to asynchronous, like asynchronous, how it works is fire and forget. There's asynchronous trigger, send message to lambda, but it's 200 after it pushed that message to this queue. And now like the clients forgot like what happened. Like they have no idea what happened. But then it's on you, since you decouple this, like it's on you to purchase all the messages. That's when you need to set this destination. When there is a failure, then so to send the invocation record to another service. And yeah, this is for like further processing for failed messages, and you can also do successful messages. So this is like basically, in general, there are two types: synchronous and asynchronous. But then there are some services that cannot trigger lambda. You follow this? There's some services it's not possible to invoke lambda. And then AWS did some small workaround, and that's what event source mapping is. Again, when I was studying AWS myself, this is one of the hardest concepts to understand. Like I had no idea what this is. Like for months, I like read it, and then it does make sense. But basically, in a nutshell, is what this guy is. Like why they come up with this fancy naming called event source mapping. Like its naming is like too fancy. Like it sounds tricky to me. But then what happens is that let's say that there are 20 services that can invoke lambda, but then there are some AWS clients, they create a support ticket saying, like, I want DynamoDB to trigger my lambda. But then on AWS side, it was not possible because this service, it's not possible to invoke a function. And then they did this workaround, source mapping. And for DynamoDB, your database can trigger lambda. Kinesis stream can trigger data. And then also FIFO can trigger data, like FIFO, not standard. If it's a standard, then it can trigger lambda asynchronously. It's there, but FIFO it can. And this is very popular service that really need to call invoke lambda. It's not. So the workaround is so basically here. So let's say here you have DynamoDB. DynamoDB that ultimately you want to call lambda function. Lambda function. So DynamoDB here, not possible. It can't do that. So AWS, their workaround they did is they called something. They have another lambda. It's built by managed by AWS. It's built by managed by AWS. So this is by AWS. Red is managed by AWS. In green, it's managed by you. So you have you want to have this lambda. And then basically this lambda, what it's responsible for is it pulls message, something like lambda. It pulls message from the DynamoDB or Kinesis. Like Kinesis is pull based. SQL is also pull based. Like cannot trigger it. Like there is some sort of function, something like lambda, that pulls the events from this source, and then lambda can invoke another function. There is no issues. Lambda can do whatever it wants, and then this something like lambda managed by AWS. This thing is called event source mapping. They just call it event source mapping. And it's not magic. It's nothing very special. It's just something like function that pulls the message, triggers the lambda, like coordinator, like event coordinator between these services and lambda. And then again, from UI perspective, as I mentioned, you will not notice if it's synchronous or asynchronous or event source. You will not notice anything. For example, DynamoDB. Just select this, you just select table, that's it. Hit click. You won't notice anything. But if you do this with AWS CLI or with SDK, then it's different. Then you have to like run this command, AWS Lambda, and it says create event source mapping. And that's like the result that I am talking. So basically, do you see here, like even now, I think to me, its name makes sense. It's because it's mapping events between this DynamoDB and Lambda. Like in DynamoDB, in Lambda, we have an event. And in the source service, we do have events. So it's just mapping those events, like in between. And if you do that, you would see this. With this console, like under the hood, it makes that calls on this front end code. So they do. That's some. It is in Kinesis event source. If you see here, like event source, it pulls the message from Kinesis because that's how Kinesis is architected, and then triggers this lambda. If it if there is a fader in between, then you can also set destination. So destination is applicable only if it's asynchronous trigger or event source mapping. For synchronous triggers, you don't. Any questions? Okay, cool. So it's like something that how it works under the hood, but I think it wasn't that hard since you learned this application decoupling. This is, yes.
How can we give feedback to the client?
Feedback. Okay, it's not really client. It's just the other services that trigger lambda. So what do you mean by feedback?
I was thinking,
Mm-hmm.
imagine this is a machine learning project.
Mm-hmm.
A client uploads an image and wants to see some output about this image. So if this is that,
I
how can we get?
I see. I got your answer, but your answer is like something. There is a client in here. Like there is a client that is calling your kind of backend, right? That's what you're. Here it's not related to client. It's like AWS is triggering one of AWS service, one of your services is triggering a client. It's like it's different. Like it's not client to application service. It's like service to service. And then like in this, so in this, the concerns you have is you have an event, you have your lambda, and one thing that, as you mentioned, there could be some errors. I understand, yeah. Like there is an event on the source, and that's supposed to trigger a lambda, but it didn't. That's the like only edge case that it could have. So in that with that edge case, what you can do is you can define destination or dead letter queue. I think that's done it. Otherwise, like if it's success or fail, if it's success, then that's good. Your lambda is triggered. If it's failed, then it's started in a queue if you configure that. Okay, in lambda, you can set environment variables. You already know what environment variable is. So, do you want me to elaborate this or more? But yes. Okay, I'll do it quickly. Like since there is a few students. So environment variable, what it helps is, like let's say that here you want to have, like in your lambda function, you are calling, let's say, third-party API. Right? You're calling third-party API, and in here, let's say that, and then you have this URL in your code base, and you push this code to your GitHub and you deploy your code and it works fine. It picks up what you have written in your code. But now that third-party API, they changed the URL from v1 to v2. And let's say that they changed this API like bluntly, and that's not backward compatible. So basically what happened is that like, they released a new version, and then now you started getting errors, 500 errors. Are you following this? And now, like the thing you need to like, you have to change this value immediately at runtime. Like you have to change this value immediately. But if you put that in your code base, if it's your in your code base, then basically you have to change your code, right? Change your code and push it to Git and get it deployed. In real life, that process takes about 2 weeks. At my last job, for instance, when we deploy something, it takes 2 weeks. Just think about this, like releasing is it impacts clients. So basically there is lots of regulations there. And then you have these different environments. You have dev environments. And once it's dev environment, like your team leads cut the release branch, that takes also like 2 weeks. And then once release branches cut, you have to test it in your test environment. And then after that, you have to promote to the next environment called the staging environment. That's production-like environment. And then finally, like release, it has to be approved by like directors, and that also takes some time. So basically, you know, when it comes to code changing, these big organizations, it takes time because that's the only way to like regulate these many systems. If you don't regulate this, like one system did the release, that impacted the other servers, and then you have it. That's why these companies release like every 2 weeks. So because of that, like let's say that now this third-party API changed this this URI, and you have to change it. If you do it in code base, it will take that long time. But if you make that environment variable, you can change at any time. So it picks up the new changes in your like immediately. And when we make changes to security group, it takes effect immediately. Similar. That's what happens, and that's just one of the examples of environment variables. Okay. So that you can configure it, and I recommend you in your labs and your project. I recommend you to read some variables from this environment variable that you can, like it said here. Like for example, here table name and table, and then environment is here. So now in your code base, you get your table name using this key, and this key is static in all environments. And now this value can be dynamic. But that's also one of the reasons why you should read table name from environment variable. In this assignment, I'm sure that you might be doing health coding, but in real life, you prefer doing it. And then this environment variable, how you read it in Node.js is like process.environment.table in our case. And then you reads this value. Anyway, it's there. Oh, one thing to note, I'm gonna add it. Secrets. So this is passwords, database password, or API keys. Secrets. Put it. You read secrets from AWS secrets manager, and then secrets manager manager injects the environment variable. Let's say here you have this database password, and the password I put while I was creating the test database is here. This is my password for database. And if you have them, now there is, like, let's say I create a new IAM user. Okay, there's something for, I create a new IAM user, let's say Bikram, okay? And he has permissions to read this. Like he needs to work on Lambda daily basis. So I give him the permission. And now that router developer can see this database password easily. Makes sense? You want to hide this. Right? You want to hide this, like now it's a key, secret key. And now that developer says, like, instead of this actual password, it's a secret key. And that secret key is stored in secret manager. And then basically you put that secret key in here. Now let's try. Yeah, in the beginning, like it looks like there are like way too many components, but now you understand the real life problem. Just managing the secrets. This is like headache to this DevOps team, like IT directors. Like this is in, like when it comes to governing this many services, it's where it's important. So here, let's say other types, and then here I put that secret key. And then my actual value is here, test 1, 2, 3. I put it in secret key, like you start with one, and no one can see it. Or at least you can say, like in your developer's role, they don't have access to secrets manager. Or they can't read. Now this is like all automatic. Okay, again, guys, there's so for this. So you have secret key that's pointing to some secret in the secret manager, and the actual value is here. And this is like automatic. Picking up this value from secrets is automatic. It's not that hard.
And we use the secrets manager to other, not AWS services, like for backing the application.
Exactly, you can do that. And I also really want to use the secrets manager. Unfortunately, it's too expensive. It's just for one secret store, it's cost 40 cents. And let's say if you have like 10, it would cost $4 every month just for restoring it. And then plus, I'm sure you might be paying for number of requests, like how you are reading it. It's too expensive. So now I'm looking into something different. So something is this expensive. So I'm sure there is some kind of services there. Or what I would recommend is if you are using GitHub, then GitHub there is something like you can store the secrets. Like on project level, you can store secrets. And your Bitbucket, you have also like Bitbucket has more enterprise features. In Bitbucket, you do have that. So my bottom line is, yes, you can use this. It's kind of expensive, and you might need something less expensive. That's what these code versioning systems can do. Like Bitbucket, they can help you with that. GitHub, they can help you with that. They are not sophisticated as this guy maybe, but still you can use it. And since we talked about secrets, like never ever push these secrets to Codebase. Even if you deleted it, it still lives there. Like someone can see the previous commit, and they can see it. So if you, that's I think also one thing. Just always keep in mind, you push something to Codebase that never gets deleted because you can always see previous versions. Let's take 10-minute break, then I'll talk about this, and this is.
Driving test failed. So I will be here like in the because getting the schedule is very tough.
Sure, yeah. Okay, that's the reason. Because on day one, I mentioned that if you want the schedule drive, yes, then
I took the schedule during the vacation. It is very hard to get schedule. Yeah,
Sure.
I'll be there by 10:30. Done with. It also, I think it was the best. It's not. You have a yes, yeah. If I can go to I just like, yeah, I'm not going. You're trying to something that Chinese Guys, it gets things on it. At least it means you go to it for the phone. Yeah. You also have one year.
So some results.
yeah, I'm done. Sure.
Say that like timeout is 15 minutes.
Yes.
So I was clicking on the internet, says that 3 seconds is the default.
Yes.
So you mean that the maximum?
Yeah, maximum. Maybe it's like these limits tend to change. Let's double check together. Function on this function is here. So yeah, like it's 3 seconds. Like default is something recommended, right?
Yeah.
And they say it's 3 seconds. I think it's something you should do with.
Yeah, 15 minutes.
Yeah. And let's just double check. It's gonna do that. It was general configuration. Timeout is here. Like what we are doing today is just this configuration. Just be bold to explore this configuration. Here. Oh, okay. Unfortunately, they didn't put it in here.
Like more than 15
Yeah, like 16. Yeah, it's still there. It looks like that. And there is no point in proving this again because even personally, in my side, I mentioned right, if it's more than 30 seconds, then you're something else. And then it's like doable, they can increase it, but no one really needs or wants that because it charges more. No one wants that.
I just saw on the slide that it says
But then-
15 minutes. And it's the way it looks is like it has mentioned about the 3 second default. So it looks like you mean to say like the timeout is 15 minutes. That's why I was confused.
Okay, this is much.
You teach also about the stages, like there's something called the staging or something. Was it Googling?
Yes.
This is smart chat thing that you try.
Sure. Yeah,
So-
I will do it like alias versioning.
Later.
Yeah.
Do it later.
Like not later, like in 1 hour.
Ah.
You would know that.
Is there all here? In my. That is using. Like a lot of. Is there any exam? The power of it on mistake is what we don't give them. You must have. Yeah, yeah, so he gave us out here. Wake up with that, actually do it. It's tracking is then but it's one of the most sophisticated bucket. If never be happy. It's very up to that. That is happening. No, he started. Like what people do. Into the subject of here in South, which is high face on which yeah, sense it's actually the it's very important. So I one of that I would pay it something happening. Talking about everyone's kid and then it's
Yes. Yes, you can. But make sure that don't change what you created for exam. In case there is dispute, then you can show it to me, right? Okay, just don't touch what you did in the exam, but otherwise you should pick up. Because yeah, yes, you can just don't touch what you created before, but you can still create and practice. Because I already created this over the weekend, so you're good to go.
So will that be recording in the afternoon? Ready?
No.
Thank you. Tomorrow there's recording.
Yes.
Tomorrow.
Now, for the next 4 days,
Okay.
like until Thursday, we have a recording.
Thank you. Sport. Yeah.
Yeah. Seeing this automatic transcribe is funner than watching some boring comedian. Okay, 2 more main concepts to go, and then we should be good. Okay, let's get started. Concurrency. Okay, this is what these 2 styles are about. It's like instead of explaining this verbally, if you take a look at these 2 strings, it just makes perfect sense. So first, you have this number of requests, 1, 2, 3, 4, 5. And this is the time is 1 second in 1 second frame. First request, it took 100 milliseconds. Like they all took these milliseconds evenly. So in that case, like 1 concurrent lambda can handle it, but it's distributed evenly in 1 second. And this is when it comes to concurrency. There is request 1, it's being processed by the first lambda instance, but then you have this concurrent request, you have parallel request. In that case, the first lambda is busy working with the first request. And in that case, this is when this lambda is scaled, right? At this point, you need 2 lambdas or 2 concurrent to process this parallel messages. And it's still working, yeah.
Like another instance is created.
Exactly. They call it lambda instance, yes. Makes sense? Yes. And then you receive this third request. But the second lambda is still processing this request. So like it has to use, like there are 2 ways. It can like use the first lambda again and use first lambda again. But if let's say that if the first lambda were busy, then it would spin up the third lambda instance. It's just concurrency, right? Just
Like
it.
thread.
Mm.
Like a thread.
Yes. But thread, I don't think it's automatic. Like you give numbers, right? How many thread you wanna. Yeah, like the way it works, it's similar. Like when it comes to processing requests, it's threads. Yes. But then when it comes to threading, if I'm not mistaken, then thread number is something you define, like how many threads. But in AWS, like it's automatic. It knows that how many requests are there and it's scaled.
Does it charge more when it creates in the number?
Yes, for sure. Because you have your event. Okay. Concurrency is the number of requests that your function is serving at any given time. And when the function call finishes running, it can handle another request. If it's not finished yet, Then there is a new request. Then there is new Lambda instances created for that concurrency. Again, another Lambda is allocated, which increases functions concurrency. And this is the most important thing that you should know. Like every service, I think I previously mentioned this. Every service has some limits. Because of that reason, you won't use this service, even if there are like million reasons you want to use. But there's one limitation that can limit all. Here, number of Lambda instances that can run in this AWS region is 1,000 by default. It's soft limit. You can create AWS support ticket to raise this limit, but by default, we have this 1,000. So basically, you can have 1,000 Lambda instances running at the time in that specific region. So basically, now we have this limited resource. When it comes to limited, then it's something that you need to manage that limited resource. I would say this is the only thing you need to manage in Lambda, because like most of the things is managed by AWS, right? The scaling and all this stuff. Again, like most mid to like a smaller like startups or a small to mid-sized applications, it doesn't care. But when it gets bigger, then it would be an issue, right? And notice here, this is not only one Lambda, this is shared by all functions in a region. Like if you have application 1, 2, 3, 4, they all compete for this 1,000 concurrency. And that's where when you need to this, you need to manage this. Like there are two types of concurrency that you need to keep in your mind. And then it can be increased. Previously, so for example, in this case, like request 1 is here, it's processed at this time. Request 2 is here, it's being processed by the second Lambda instance, and request 3 is here. And I would say this will be processed by the first Lambda, because the first Lambda is finished. Exactly. And then your question is, like in AWS, scaling is automatic. Right? It can scale out automatically if there is a concurrent request, and there isn't any Lambda that can process a new request. The question is like how it scales out? Scales in or remove instance to save some cost. And I googled this, and this is what I found. Like the Lambda is still warm. Like it stays for 30 to 45 minutes, and then it's removed. This is something. And then concurrency control. Yes.
You said we're gonna, our function has to run for a long time. We shouldn't prefer you to because we charge more.
Yes.
So what about the warm up? I would just this kind of fine, right?
Yes, like again, yes, exactly. Then that was it. Like we talked about this long running Lambda in terms of cost, and also you can see here like it can kill your concurrency because there is one request processing. One Lambda is used up for one request for a long time. So when there is a new request, like the only way to process that request is like instantiate new Lambda instance. So that's the like second thing. Like in terms of cost, in terms of concurrency, never create these long running Lambdas. So answer to your question is like there are some issues. Yes, you are right. Like you noticed, correct. Let's move on. Now let's say this limit is shared across all functions. Now there could be many functions. Let's say the same function for production and dev environment. And I'm sure that you would want more concurrency for your production environment. For dev environment, it's okay to have a little bit throttling. Like if it reaches that 1,000 instance limit, then you get throttling. Like it will load forever until there's a new instance available for that request. And then you wouldn't want that throttling in your production environment, right? And you want to give like enough concurrency for your production environment, production Lambda function. That's when this reserved concurrency comes into the picture. Makes sense? The second thing is provisioned concurrency. It's related to this cold start. Lambda is just a small function, but instantiating this function takes less than 1 second. Let's say like 800 milliseconds, I would say. And that's still a lot of time. Like some applications, they cannot afford 800 millisecond latency just for this. For the first request, it takes longer time because the AWS needs to instantiate the new request. But once that instance is warm, then it will not take that time. Let's say that the average processing time is 2 milliseconds. In that case, the first request gets 3-digit millisecond, and after that, it will take 2-digit millisecond. That's what cold start is. And this provisioned concurrency, you define this, let's say 100. In that case, there will always be 100 Lambda instance up and ready to serve new requests, or they are like warm. So you can resolve this cold start problem. Good. So yeah, this is kind of problem. Like some of my friends were developing side project, something like story, so they can do video and stuff. And they did that in AWS typical this infrastructure, Lambda, DynamoDB API Gateway, and they had really hard time with this cold start. It's like 3 years ago, I think. And then this provisioned concurrency, I think it's released two years ago, and now this cold start problem can be remediated with this provisioned concurrency. That's pretty much all. I found some pictures from the official documentation. So reserved concurrency in production, like let's say like you have this 1,000. So it looks like you assigned this 300 or 400 concurrency for your production and 300 for your development function. Looks like this. My function looks like it's like the main function that runs your business, I would say. Like you have one API, api.yourcompany.com, and then that API, behind that API, like this my function is running. So it looks like this my function is mission critical, the most important function. So that's why you need to like reserve some concurrency. And production, as you see here, it's going smoothly. It's not hitting the threshold or limit. But when it div and other functions, they intermittently hit the limit, that 1,000 limit that you see in here. In that case, you would get throttling. So div environment is fine. And then let's say like it's 300, this is 400. And the rest of the 300 concurrency, it will be shared by other functions, all other functions. Makes sense? Good. Next, nothing is fancy here. Just like the previous image, okay? Just previous image. The only thing is, do you see this part? This part is provisioned concurrency. So basically, until this, you would not face code that says start problem, but it's more than this lines, then you would get code that start problem here, like 3 millisecond. Just combine this. Okay, so this concurrency is something that you should know as a Lambda developer. It might be in the exam or in the interview, but in real life, like currently, I haven't faced such issues. It's not like common thing that you manage. Like if you have many applications, like many functions, if you have like one account for entire organization, then you might face this issue. But otherwise, I would say like 90% of the time, you don't have to do this. It should be okay. Okay, just to summarize this slide, I'll summarize two things from this concurrency. The first thing is you do have this limit that by default you can have 1000 Lambda instances. So this limit, keep that in your mind. And based on that, you will decide like if Lambda is really a good choice for your application or not, right? If it's like more intensive application, then maybe you shouldn't use that. The other reason is there is something called cold start problem. It takes like 3-digit millisecond to instantiate Lambda instance. To have that, you can use provisioned concurrence. So I would say these two. So versioning, and sure. Which one? This one?
This one, the height is representing the 1000 instance.
Yeah, I'm just making
So is there any priority? Like I can, of course, I want to give the priority to production, then development, then other. So the mechanism to give priority to the function category, something like that. Because in 1000, I have 1000 instances. Of course, I want to give the most priority that my production service should not never go down. Maybe the second.
Yeah, like more concurrence.
And give priority to our lambda functions.
I think you already gave priority in here. Like it's important, so like take 400 concurrency out of 1000. You already gave it. Like you got that priority. That's the reason why you would consider this reserved concurrency. If there is no such priority, then there is no, like you don't need to do this. Okay, in Lambda, let's create one new Lambda. So this demo, yeah, let's do this. Yeah, Lambda. And then, okay, so this is very small demo, so node 18 should be okay. So execution role, this is what this can do. I'm gonna select this tab role. Hit create. Okay, let's say we have this Lambda and we do have some. Okay. Let's implement this Lambda. Okay. We did the do team, and what we did is like version 1. Okay, we implement our Lambda, like very simple Lambda, version 1. Okay, so deploy this. You can create new version here. Create, publish new version. And this new versions are published like it's incremental 1 by 1. So 1, 2, 3, 4. You can give a description optionally. So I don't care. I just create V1. So V1 in here. And one thing to notice, this is your Lambda ARN, regular Lambda ARN. And then you have column, and then you have this here. This is Lambda ARN. and then you have column, and then you have version 1. Because now you want to manage multiple versions, right? And you want to call a specific version. And you want API gateway to call version 1, not version 2. That's like it's dependent on the notice that. So notice that. So it's there. It's version. So you can, once you create a new version, you cannot change it. It's immutable. That makes perfect sense. Here, triggers. Now we're gonna code preview, so you can change it. So let's test it. So we are not capturing any information from event, so we don't care about what we will have. So pass it. Version 1 makes sense, right? Go back to this version 1. Go back to Lambda 2. And version 2. Okay, hit deploy. So we made some changes to our code and create a new version. Let's create a new version, and this is gonna be version 2. Well, that's what version is. Like you have these different versions. The next thing is alias. That's something so interesting and super powerful. Like as an engineer, what I like to do is like I want to do like a few things to achieve great thing. And have you ever heard of something like canary deployment or blue-green deployments strategy? Those are okay. Take a look at it. It's worth knowing what like get the context. Okay, blue-green deployment. This is like you have the blue, like you have your current version, and you deploy the new version, and they are running at the same time. So one is blue is I think all green is the newer one. And then once you tested the green one, the newer version, you change your now your application URL will point to the new version. Blue-green, like this is something big. And at my last job, we had this many monolith legacy applications. And then to achieve blue-green deployment, like multiple teams worked for 1 or 2 years just to achieve this blue-green deployment. Then the next deployment, canary deployment, that I will show you now, that's like more advanced. And in Lambda, you can do it just a few clicks in 1 minute. But again, like this complex deployment blue-green, that was done at my last company, like many teams worked for 1 year and they achieved that. It is something like now you will not notice, maybe you will not notice, but this is a big something. It's a big deal. So now let's create alias. That's this alias, it helps us. So basically, let's say this prod. Production, this lambda, instead of pointing 1, 2, 3, we want to point to like prod. In prod, it will point to version 2. Makes sense? When you do prod, it would send request to version 2. And now let's say you deployed your production environment and there is something wrong with this. You want to roll back. What you will do is just go to here, switch to version 1. It's super easy. Like it's easy to like roll back. That's, by the way, one of like there is AWS Grid Architect framework that you can follow to build better applications. And there are 6 pillars. One of the pillars is operational resilience. That's basically what talks about this rollback. I guess you have to do this in your application. Yeah. Okay, that's first thing. The second thing is what canary deployment. Can you stay like 20 more seconds? Just 30 seconds. Okay, I'll show you this. Okay, so here, emergency. Okay, sure, then you can. Anyway, so here, it's pointing to version 2. Okay, original version is V1. and we do have our new version 2. So you can add this additional version, and you do this weighted routing. Like, since it's a new production environment, I will put it like 10%. 10% of the request will go to the newer version, and then 80% will go to the other version. That's what Canary deployment is, and it's like built-in supported. So I would do like 50%, and if you check your logs, check your dashboard, if everything is successfully green, then you can shift entirely. Let's say 1, 2, 3, 50. And now we can test it. It's 50%. And this is V2. Keep testing. Still V2. Make it a bit smaller. Okay, V2, V1. V1, V1. There should be V2. So, okay. Anyway, you got it. So, I think there's one warm instance there that's handling out. Like, this is just log out. It like takes 1 millisecond. So. Okay, V2. You have to click it like real fast. So anyway, this is here, and this is the only in terms of Lambda, and there are many other ways to implement this Canary blue-green deployment in different services. That's what AWS white paper is. Like, you will learn a lot. You will learn many things. AWS white paper. Just this one, just Piper, and then like learn about blue Canary deployment. Yeah, something like this. There should be. Okay. Anyway, so this is something that we did on the Lambda. So you can achieve this similar Canary deployment using services that works on top of Lambda. Like in Raft3, you can also do something like that. And that's like when you can get more details in the white papers. If you are using it just a container service, you can also, like, there is a way. And like this high up folks out there, like CTO, like all these big people, what they want is they want something like, okay, they say something like from a business perspective, and they say like, we have this many outage. This is the reasons that we lose money. So maybe we need to consider blue-green deployment. And then they give this task to like some team lead. And then they look at this AWS white paper and implement that. Anyway, so there are many ways. Okay, that's what version and alias is. Well, that's pretty much all. I hope you enjoyed the demo. I'm not required. Yeah, so this is something you do it yourself. Like in my previous class, I had assignment for only this Lambda to practice what I demonstrated and so on. But then this time I just focused on the main thing. So I removed that from the assignment. So basically, if you want to do this, do it. You can have file storage. So by default, Lambda has 500 megabyte temporary file system. Like, it comes when Lambda instance is created, and it's deleted when Lambda instance is removed. If you want something shared and durable, that you can mount EFS into Lambda. But that's pretty much all. It supports that. You can. There's something called database proxy in the configuration. You might notice this is used for connecting to a Redis database. Okay. You wanna run this. But personally, I don't recommend this. The reason is this. So it takes a lot of resource to create connection in a Redis database, right? If you have lots of connection, then your database suffer from, like when you query, it will take longer time because most of the resources for maintaining connections. And then think about Lambda. It can scale instantly. It can even scale. It can scale out 1,000 instances in 1 second. Let's say there's 1,000 concurrent requests, and you have that. Let's say maybe you created the AWS support ticket, and now you support more than 1,000 concurrents at a time, and then you assign it 1,000 concurrents to one function, and then it basically it can scale to 1,000 in 1 second. Do you think that RDS can handle 1,000 new connections in 1 second? I don't think so, because even maybe your database might blow up. So that's what I think. That's why people use this DynamoDB in conjunction with DynamoDB, because now they both can scale instantly. DynamoDB is, I would say, it's the world's most powerful transaction database. Like it supports trillions of transactions a day. Like it only focused on this transaction. If you need analytics, then you have some other services. No, sure. So, but it's possible, so you can do it. Some pricing, I read some blog. It's not very expensive. Let's say the numbers are very big. Okay, so for example, provision Lambda, so it costs more. Like if you do something like provision, now think about this. Now it's the way it works is similar to EC2 instance, that you have some instance always up and running. But by default, the nature of Lambda is like it's created when there is a new request. Anyways, and then because of the provision is super expensive. So for every gigabyte second, and this Lambda is like relatively big, 500 megabyte memories. It's not that small. And then it calculated this. And the maximum memory. Okay, where is it? Okay, this is some pricing. If this memory is here, it would cost this much. If its memory is like it's based on the memory. So this is, I think, the point of this second bullet point. The bullet point is again, if it's 500, then it costs here. If it's 2 gigabyte, okay, this is multiplied by this. So basically, this request is multiplied by memory size. And okay, here is the actual computation. I think this is the point you are interested in. So 500 megabyte memory, 10 million requests with duration of 2 seconds. So here you will talk about millions. 10 million requests, each takes 2 seconds, and it has 500. So when you calculate it, so this invocation here for 1 million invocation, it costs $2, and 10 million, so it's 166. And if there are some Lambda instances provisioned, then it costs even more. So basically, think about this: like for 1 million, it would cost like 16 bucks for 1 million requests. So it's very cost effective. Yeah, and then there would be like just a few, let's say, 50. We can calculate this easily. Seconds in days. And it's a big number. Like when you have only 50 Lambda, like let's say the average Lambda that is used number of instances that's used for verification is 50, then it can handle this 4 million requests a day. It's a big number, right? It's just one number. If you multiply by a month, then it will take how much? Like 100 million requests every month. But these numbers are still big. Right? Even if 50 at the time, it's a big number. Okay, this is like how they calculate, and this is like average price. For 10 million, it would cost 166. And if it's average, if it has some provision instance, then it costs more. And so this pricing is based on how much memory you have, and the maximum memory you can have for Lambda is 10 GB. This is also one limit. And then some more informational slides. So Lambda best practices. So here, you can, so if you are creating database connection, for example, you are connecting to DynamoDB. In that case, when you instantiate, like, do you remember how we instantiated SNS in the SDK? We did that outside of the function. When you do so, that connection is shared across all Lambda instances. But if you put that inside the function, then it will create that every time. And that instantiation takes some time. And if you are importing another library, that will impact your when you are launching new Lambda instance. Makes sense? Like when you have one dependency, let's say it takes 300 milliseconds, and you added the second Lambda, that might take 200 milliseconds. If you had the third, then it will take, like it would add up, it would make your code much slower. And then then you learned that your second library, you don't need it. And then if you remove that, then you can reduce your latency, constant latency from this 500 to 600, so 300, so which is like 40% faster. So only import required libraries. And Lambda is used, some people say use it for transforming, not for transporting. So basically, currently, we are using Lambda for transporting. Like in Lambda, when you use SDK, when you call other service, that's you transporting data from Lambda to the and then this transportation takes time. Like you do like a wait. Like let's say that the storing, like calling that API takes like 100 milliseconds. And then you pay for it, right? Since you're Lambda wait. And the same call you can do with the step functions, if you remember. The step function can do the same thing, but it will not cost like Lambda. Lambda will cost while it's waiting the response from whatever it costs. So basically that's here. But Lambda can be used for transforming. For example, your clients send XML data, but your backend expects JSON, and you want to transform it. In that case, it's like business logic. You should do that. Like you can do it in Lambda. But if you are passing data from A to B, do not use Lambda. Use the step functions.
Even though we are using step function like we did in SNS or SQS, our message is still passing, right? To the Lambda function.
Yes, Lambda, but only for transforming purpose. Like not sending. So sending that message to SNS, that is done by step functions. I think I didn't give that problem statement. Like my problem statement wasn't that clear. That's why you might face the similar thing. So I updated my assignment description. So this is, so what I wanted to test out was this. It's just injecting one value. It's no longer sending that sends message. So this one. So this is what I meant by this transforming. You're sending message to this service. And do you see this await? Await simply means you're asking Lambda to wait. Lambda charges when it's waiting, right? So and then this kind of operations you can do it in step functions. So looks like I need to look into like how step function pricing works, but I don't think.
Maybe that's why we don't write any code in step function. We just name the function, but there is no code.
Yeah. Oh yeah, this is step. So here I just inject some value here. Anyway, okay. Basically, I refactored this code. So I had this code. So it sends message to SQS. And then instead of this, I use the step function. And my Lambda, what it does is it's just doing some business logic transforming. And let's assume that this is not send message. Send message doesn't take that much time. Let's say it's calling third-party API. Then like, which one will run faster? Like this one will faster like 100 times, right? 100 times faster than the previous one. So we use your cost 100 times. And when it comes to scaling, so what in AWS, what people do is scale out. That's the proper way to scale. And when you scale out, add and remove instances at any time. If there is an state, then that will be an issue. So then I just iterated on that point in here. I just kept this style. So basically, the state is you have a client and you have a server A, and server A remembers this client A's information. And now this client A is tied with server A. So that's what the stateful is. When you have such things, and now let's say there is master, you want to remove one of the server, and maybe AWS choose server A. If they terminate service A, then client A would have an error. Like they will start getting 500. So that's why that service shouldn't remember any information in a state. Instead, what you can do is you can store it in a shared place that they can run. Like in DynamoDB, as I mentioned, you can use DynamoDB, and reading data DynamoDB is like reading from memory, reading from cache. It's like 2 digits millisecond. So it's just that you can plan to read it. So Lambda, you need it when you don't have many developers to manage, like for some side project or small startups, and you wanna like do something fast. You wanna deliver your product faster. Your first product, you wanna deliver it fast. You can use Lambda, and also a number of transactions are unpredictable. Like you have no, like you can't guess it. So that if you can't guess it, then how do you come up with like silver size? It's not possible. In that case, you can use Lambda. And again, it's because of this concurrency limit. The maximum number of transactions are hundreds or thousands at the time. I would say it's not hundreds, thousands. Like if you need something huge application that you need like more than that, then you need like a fleet of EC2 instances. If you need more than that, then you can use EC2. And if you can predict like number of transactions, let's say, okay, for this university, we know that like there are like this number of students, so we can come up with like some instance size. And if you need like more control over your application, in that case, you can do it. Like if you need more control, you can do EC2. But the trade-off is, you have to do a lot of things. You have technical rules. And I read this Medium blog, and here it showed the pricing. There is pricing when there is an application with 2 gigabyte memory and 1 CPU. When you have this instance, this Lambda, it looks like it costs more. And then there is ECS and DC2. I checked out this, and this is like some interesting research that this blogger did. So check this out. Okay, that's pretty much all from me. You can cut out. This afternoon, we will talk about. I'll give you your exam papers so you can see which parts you missed.
See tomorrow.
Yes, yeah.